Hi students, today I will explain chemical bonding and molecular structures. So chemical bonding is one of the important chapter in chemistry. Now, what is the definition of chemical bond? So chemical bond is nothing. So just it is one of the attraction. Okay? So it is an attractive force which holds atoms or ions together in a molecule. Okay? So chemical bond is an attractive force which holds atoms or ions. So example wise, hydrogen molecule is formed by the attraction of two hydrogen atoms. Okay, so in between two hydrogen atoms, attractive forces are developed. So therefore, hydrogen molecule is formed. Along with that, 437 kilojoules amount of energy is released. Okay, so that's why this formation of a chemical bond is an exothermic reaction. Okay, so in the formation of a molecule, energy is liberated. No? So that's why it is a kind of exothermic reaction. So why it is exothermic reaction? Because here initially see that atoms are less stable and more energetic. So why that atoms are less stable? Due to having non-octet configuration. Generally in periodic table we know that all the atoms except the 18th group of elements have non-octet configuration. Okay, so that's why those elements are less stable. No? So for getting stability, those elements or atoms are combined to form as molecules. Okay, so therefore molecules are more stable. Okay, so molecules are more stable and less energetic. Okay, so now here the important point is that atoms are less stable and more energetic, but molecules are more stable and less energetic. So that's why the formation of chemical bond is one of exothermic reaction. Okay, it is a kind of exothermic reaction. Now, types of bonds. So what are the types of bonds? So that are generally ionic bond, covalent bond, dative bond. So here majorly four types of bonds are there. Ionic bond, covalent bond, dative bond and hydrogen bond. Okay. So let me discuss about ionic bond. Ionic bond is a strong electrostatic attraction. So this point is important. Okay. So ionic bond, it is a strong electrostatic attraction between oppositely charged ions. Oppositely charged ions means cations and anions. And next, it is formed by transfer of electrons. Okay, so it is formed by transfer of electrons or losing and gaining of electrons. Losing and gaining of electrons. Okay, so therefore, that number of transferred electrons is called as electrovalency. Number of transferred electrons in a compound is called as electrovalency. Okay, so therefore ionic bond also called as electrovalent bond. It is also a type of electrovalent bond. Okay, so now in this see the example, that is formation of magnesium fluoride. Formation of magnesium fluoride. So how magnesium fluoride is formed? In this, first magnesium loses its two electrons. Okay, so that losing electron, magnesium losing its valence two electrons. Okay, so losing electrons is called as oxidation, and two fluorine atoms gaining two electrons which are released from magnesium, and then it changes to two fluoride ions. Okay. So here gaining of electrons takes place now. Therefore, this reaction is called as reduction reaction. Okay. So now see, in the formation of magnesium fluoride, oxidation as well as reduction process takes place. Therefore, this formation of ionic bond is one kind of redox reaction. Redox reaction. So in redox reaction, oxidation and reductions are added. Okay. Now see the electrovalency of magnesium in this. So how many electrons are lost from magnesium? 2 electrons. Therefore, the electrovalency of magnesium is 2. And how many electrons are gained from one fluorine atom? 1 only. Therefore, electrovalency of fluorine is 1. Okay. So, initially I said that number of transferred electrons is equal to electrovalency. Okay. So, therefore, electrovalency of magnesium is 2. Electrovalency of fluorine is 1. Now, here, so generally I said that ionic bond is formed in between cation and anion. Okay. So now here the discussion is that which factors affect the formation of cation and anion. Okay. If cation and anions are there, then electrostatic attraction occurred in between of the oppositely charged ions. Okay. So therefore ionic bond is formed. So before of that, how cation is easily formed and anion is easily formed. Let me discuss about which factors affect the formation of cations and the formation of anion. Okay. So first topic is about cation. So in cation, low ionization enthalpy of atoms. Low ionization enthalpy of atoms easily formed as the cations. Okay. So ionization enthalpy means already we know about ionization enthalpy. So that is the minimum amount of energy. Okay. So I'll write just here the minimum amount of energy which is required to release electrons. Okay. So the minimum amount of energy which is required to release electron from a neutral gaseous element. Okay. So that's why here neutral gaseous atom always loses its electron by absorbing energy. Okay. So this energy only called as ionization enthalpy. Okay. So low ionization enthalpy of elements easily loses the electrons. Therefore they convert the cations. Okay. So that's why here the point is that low ionization enthalpy of elements. Easily converted to the cations. Now, here we have to take a first group of elements. Okay. So, in any group from top to bottom, ionization enthalpy decreases, no? So, therefore, for cesium element, ionization enthalpy is low. Okay. So, therefore, that cesium easily loses its electron compared to the rest of the elements. Okay. In that group. So, therefore, lithium ion, cesium ion. If we compare lithium and cesium ions, cesium ion is easily formed as its cation. Okay. So, therefore, low ionization enthalpy is preferable for the formation of cation. And next, second point is that low charge. So, charge also low. So, means what? Suppose if we take off two cations like sodium ion, magnesium ion, aluminum ion. So for sodium ion, plus 1 charge is there, but for magnesium ion, plus 2 charge is there. So when we compare sodium ion and magnesium ion, sodium ion is easily formed than magnesium ion. Why? Because here sodium is losing its 1 electron only. Okay, but magnesium is losing 2 electrons now. So losing 2 electrons is difficult compared to losing 1 electron. So therefore, in sodium ion and magnesium ion, sodium ion is easily formed. Okay, so therefore, low charge is preferable. And next, third factor is the large atomic size. Large atomic size. Okay, so in any group from top to bottom, atomic size increases. Already we know about that. Okay, in any group from top to bottom, atomic size increases. Now, example purpose, I took that second group of elements. So what are the second group of elements? Beryllium, magnesium, calcium, strontium, barium, radium also. Okay. So in these elements, the atomic size of barium is large. So therefore, for this large atomic size of elements, nuclear attraction is less. Okay. So nuclear attraction is less. Therefore, it easily loses its outermost electron. Therefore, it easily loses its outermost electron. So, therefore, comparatively, if we take beryllium ion and barium ion, the barium ion is easily formed. Okay. So, means large atomic size of elements easily converted to their cations. And next, fourth point, octet configuration of cations. Okay. So, here octet configuration of cations are formed as ionic compound. Okay. So in sodium ion, magnesium ion, zinc ion. Okay. So now example wise, here I took the three types of cations. So what is the specialty of these cations? For sodium ion and magnesium ions, octet configuration is given. But for zinc ion, pseudo-octet configuration. Okay. So octet configuration means what? Possessing 8 electrons in its valence shell of an atom. Okay. So that is called as octet. Pseudo-octet possessing NS2 NP6 ND10 configuration. Okay. Possessing NS2 NP6 ND10 configuration. So in the now with example purpose, here I took the two compounds, sodium chloride, zinc chloride. So which compound is ionic? Okay, so in these two compounds, here we have to identify which compound is ionic. So which one is ionic? Sodium chloride is ionic. Okay, so why? Here sodium ion has octet configuration. This octet configuration of cations are always formed as the ionic compounds. Okay, so zinc chloride is one of covalent compound. Now these factors affect the formation of cations. Okay, one is low ionization enthalpy, low charge, large atomic size, octet configuration of cations. Now go to anion. Okay, so again, which factors affect the formation of anion? So in this case, first point is that high electronegativity. High electronegativity. So what is meant by electronegativity? It is the tendency of attracting electrons. It is the tendency of attracting electrons. Okay. So now electronegativity, if we have to take off 17th group of elements, okay, from top to bottom, in any group, electronegativity decreases. Okay, therefore, more electronegativity is given for fluorine and less electronegativity is given for iodine. Okay, so therefore in fluorine and iodine, which atom is easily converted to the anion? So that is fluoride ion. Okay, so fluoride ion is easily formed than iodide ion. So therefore more electronegativity of elements easily formed as the anions. Okay, and second point is that low charge. So low charge is preferable. Means what? Example wise, here I took fluoride ion, oxide ion, nitride ion. Okay, so fluorine atom is gaining 1 electron only, but oxygen atom is gaining 2 electrons and nitrogen is gaining 3 electrons. So now here gaining 1 electron is easier than gaining more electrons. Therefore fluoride ion is easily formed than oxide and nitride ion. And next factor, small atomic size. Small atomic size. Small atomic size of elements always formed as the anions. Okay. So again, if we take of 17th group of elements, 17th group of elements, atomic size increases from fluorine to iodine. Okay. So therefore fluorine is totally small in size, no? So for small size of elements, nuclear attraction is more. Why? Though in those elements are totally nearby the nucleus. Okay, electrons are totally nearby the nucleus. Therefore, the tendency of attracting electrons is easy. So therefore, fluoride ion is easily formed than iodide ion. Okay, and next, octet configuration of anions. Octet configuration of anions are formed as ionic compounds. Okay, so that are chloride ion, fluoride ion, all these are. So these 4 factors are favorable. Okay, but again see that for the formation of anion, high electronegativity, low charge, small atomic size, and octet configuration. So these 4 factors are preferable for the formation of anions. Okay, with these factors, cation and anions are formed. Okay, so in between of that cation and anion, ionic bond is present. Okay, so more strong electrostatic attraction is present. So therefore ionic bond is formed in between of the cation and anion. Okay, so this is about ionic bond. And next I'll discuss about properties of ionic compounds. Properties of ionic compounds. See here I given in simple manner to easily understand. Okay, so that's why if you see once it, then you will get that. See and listen. Okay, listening also important. So in properties of ionic compounds, so what are that? Ionic compounds are hard. Why these are hard? That is since the presence of strong electrostatic attractions. Okay, strong electrostatic attractions are present, no? So that's why these are strong. Okay, therefore with strong attractions, those are attracted strong. So therefore for ionic compounds, melting point and boiling points are high. Melting and boiling points are high. See here the reason also I given. Okay, and next, ionic compounds are non-conductors in solid state. Non-conductors in solid state. Okay, but in liquid and aqueous state they act as good conductors. So now see the reasons why these are non-conductors in solid state. Because in solid state all the ions are closely attracted with each other. When those are closely attracted with each other, then there is no movement of the ions takes place. Okay, then there is no movement of ions. So therefore they act as non-conductors, especially in solid state. Okay, but act as good conductors in liquid and aqueous state. Why? Here the reason is that due to the movement of ions. Okay, so these are not closely attracted with each other. No? So that's why movement of ions takes place. Therefore, these substances in liquid and aqueous state acts as good conductors. Okay, see here reasons are important. And next, ionic bond is non-directional bond. Okay, so why it is non-directional bond? Because when one atom is losing its electron, in that direction only the other atom attract the electron. Okay, so that's why there is no direction for losing electrons as well as gaining electron. Therefore, ionic bond is non-directional bond. Ionic bond is non-directional bond. Okay. And next, ionic compounds are polar in nature. Okay. So therefore, polar compounds are always soluble in polar solvents only. So that are water. Example, water and some more compounds also there. In that one is water, alcohol, like that. Okay. Ionic compounds are polar in nature. Polar means what? Two opposite charged atoms of substance is called as polar substance. Okay. So generally in ionic compounds, already I said that cation and anions are formed. No? So that's why those compounds are always polar in nature. Okay. In this two opposite poles are present. Therefore that is polar. That polar substances always dissolve in polar solvents only. So polar solvents are water, alcohol, like that. Okay. Means these are insoluble in non-polar solvents. Insoluble in non-polar solvents. So why these are insoluble in non-polar solvents? Because these are polar in nature, no? And next, what is the example of non-polar? That are benzene and carbon tetrachloride. Just a minute. Now next topic is a covalent bond. Okay. So next type of bond is covalent bond. So covalent bond is formed by sharing of electrons. Okay. So why that sharing of electrons takes place? That is again for getting more stability only. For getting more stability, some atoms lose the electrons, some atoms gain the electron, and some atoms share the electron. Okay. If the electrons are shared with each other, then a covalent bond is formed. Okay. So that number of shared electrons from the atom is called as its covalency. Number of shared electrons from the atom is called its covalency. Now see the example. Here I given three examples. Okay, no? So first one is chlorine. Okay, chlorine molecule. In between of these two chlorine atoms, a covalent bond is present. So why a covalent bond is formed here? Because now see that in general configuration of chlorine has 7 valence electrons. No? Okay, I indicated that 7 valence electron on each chlorine. Okay, so now one chlorine atom is shared with the 7th electron of other chlorine atom. Okay, so that's why when we compared around chlorine So 8 electrons are observed. Okay. So therefore, in between of this chlorine, in between of this covalent bond is formed. Okay. Now the covalency of chlorine is 1 only. Covalency of chlorine is 1 only. Okay. And next, see about oxygen. Okay. So around oxygen generally 6 electrons only present, but 2 electrons are shared from one oxygen atom. So therefore the covalency of oxygen is equal to 2. And next, in case of nitrogen molecule, 3 electrons are shared. Therefore the covalency of nitrogen is 3. Okay. So covalency of chlorine is 1, here 2 and here 3. So why? That depends on the number of shared electrons. That depends on the number of shared electrons. Now, here types of covalent bonds. So covalent bonds also divided into two types. What are they? Sigma bond, pi bond. Okay, no? Sigma bond, pi bond. So it is formed by, first I will discuss about sigma bond. It is formed by straight overlapping of atomic orbitals. Okay, here this point is important. Sigma bond is formed by straight overlapping of atomic orbitals. Pi bond is formed by lateral or partial overlapping. Okay, so lateral or partial means slightly overlapping of atomic orbitals. Now, here if two p orbitals are overlapped in straight direction, okay, so in between of this a sigma bond is formed. Okay, so why? This straight overlapping is very strong. Okay, so therefore a sigma bond is formed by the straight overlapping of atomic orbitals. And next, now pi bond is formed by lateral overlapping. Diagrammatically we will indicate in this way. Okay, so now sigma bond is strong bond. So why it is strong? Straight overlapping is very strong. Straight overlapping is very high. So that's why it is the strong bond. Okay, but partial overlapping is not strong. So therefore it is one of the weak bond. And next, in between of any two atoms, in between of any two continuous atoms, sigma bond only formed first. Okay, so first overlapping will be takes place in straight direction. After that only partial overlapping takes place. Therefore, the first bond in between of any two continuous atoms will be sigma bond only. But pi bond is always formed after the formation of sigma bond. Pi bond is always formed after the formation of sigma bond. Okay. And next, sigma bond gives the structure of the molecule. So here with example I will explain. In H2O molecule, generally we know the structure of water. So what is its structure? Angular. Okay. So this is the structure of water. Okay. So here oxygen and hydrogen atoms. Oxygen and in between oxygen and hydrogen atoms, two sigma bonds are present. Okay. So means straight overlapping is observed here. So that's why these two are the sigma bonds only. So therefore just now I said that the first bond in between any two continuous atoms will be sigma bond only. Okay. And next, so with the arrangement of these bonds, with the arrangement of these sigma bonds only, we said its structure is angular. Okay. So we confirmed its structure is angular. And next, pi bond does not give the structure of the molecule. Pi bond does not give the structure of the molecule. So here, example, now I took that acetylene molecule C2H2. Okay, so its structure is linear. How we say structure is linear? First, arrange the atoms in this way. Okay, two carbon atoms are arranged at the center and on the either side hydrogen atoms are present. So, in between any two continuous atoms, straight overlapping will be takes place. Okay. So, therefore, three sigma bonds are observed in this molecule. Okay. After the straight overlapping, partial overlapping will be takes place. So, therefore, two pi bonds are observed in this molecule. So, now the point is that pi bond does not give the structure of the molecule. With pi bonds, we will not confirm the structure. Okay, but with sigma bonds, we will say the structure of the molecule. So these are the differences between sigma bond and pi bond. Sigma bond and pi bond. Okay, so sigma bond is formed by straight overlapping of atomic orbitals and pi bond is formed by lateral overlapping. Okay, so this overlapping is said to be straight and this overlapping is said to be partial. It is strong and next pi bond is weak. The first bond in between any two atoms will be, any two continuous atoms will be sigma bond only. Okay, but pi bond is formed after the formation of sigma bond. Sigma bond gives the structure of the molecule, but pi bond does not give the structure of the molecule. Okay, so for that these are the examples. Okay, so now we'll discuss about properties of covalent compounds. Properties of covalent compounds. Okay, so covalent compounds are either solids or liquids or gases. Okay, so example wise, iodine is solid, bromine is liquid, fluorine and chlorine are gases. Okay, so that's why. So generally ionic compounds are solids only, but covalent compounds are either in solid state or liquid state or gaseous state are present. Okay, so melting and boiling point of covalent compounds are low. Okay, melting and boiling point of covalent compounds are low. So why this melting and boiling point are low? That is due to presence of weak van der Waals forces. Okay, in ionic compounds, strong attractive forces are there, but here weak van der Waals forces are present. Okay, so therefore the melting point and boiling point of covalent compounds are low. And next, but here exception cases are there, except silicon carbide. Except silicon carbide. Silicon carbide is commonly pronounced as carborundum. Okay, diamond, boron nitride. Diamond, boron nitride. These compounds are covalent in nature, but for this, the melting point, boiling points are high. So therefore, these are the exception cases. Okay. And next, covalent compounds are soluble in non-polar solvents. So generally, covalent compounds are soluble in non-polar solvents. And next, covalent compounds are non-conductors of electricity. Okay. So why? Because in this there are no free electrons, there are no ions. Therefore, these substances act as non-conductors or insulators. Okay, that is majorly due to absence of free electrons. Again here exception case is there, except graphite. Okay, so in graphite one free electron is present. Therefore, it acts as conductor. Okay, but common point is that covalent compounds are non-conductors. And these covalent substances are simply divided into polar and non-polar substances. Okay, so in polar substances, electronegativity difference will be not equal to 0. So means what? There is little bit or more electronegativity difference. Okay. So generally see the examples: hydrochloric acid, hydrofluoric acid, water, ammonia. Okay. So here hydrogen belongs to first group, chlorine belongs to 17th group. Okay. So in periodic table it is arranged at left side and it is arranged at right side. Therefore there is electronegativity difference. So that's why that electronegativity difference is not equal to 0. Okay. And two opposite poles of substances are called as polar substances. Two opposite poles. Okay, one atom possesses partial negative charge and the other atom possesses partial positive charge. And next, non-polar substance. This non-polar substance is also termed as pure covalent compounds. Pure covalent compounds. And these also said to be homonuclear atoms. Homonuclear atoms. Okay. And next, in non-polar substances, electronegativity difference is 0. Okay, these are very important parts. For polar substances, electronegativity difference is not equal to 0. But for non-polar substances, electronegativity difference is equal to 0. Okay. So in these chemical compounds, actually, there is no compound should be pure ionic and no compound should be pure covalent. Okay, pure means 100%. In these ionic and covalent compounds, ionic and covalent. Just now we studied this ionic and covalent compounds, no? So 100% purity is not there. Means for all that compounds, either covalent or ionic nature is there, but that nature is not 100%. So that was explained through Fagen's rules. Okay. So here Fagen's rules is majorly explain the covalent character of given substance. Okay. For which compound covalent character is more, for which compound ionic character is more. If we know about covalent character, then opposite points are related to ionic character. Okay. So that's why here I explain the covalent character. Okay. So majorly Fagen's rules explain the covalent character of given substance. So here simply I said that 4 parts. So see that covalent character. Okay. Covalent character is directly related to anionic size. Covalent character is directly related to anionic size. Okay. So now let me take off anions. That are 17th group of elements. From fluoride ion to iodide ion, ionic size increases. Okay. So here on increasing anionic size, covalent character increases, no? So that's why for a given cation, covalent character increases with increasing anionic size. Okay. So in this example, lithium ion is common. Okay. Fluorides, iodides are different. Fluorine, iodine is different. Okay. So the anionic size means iodide ion size is more compared to fluoride ion. So that's why for lithium iodide more covalent nature will be given. Okay. So more covalent compound in lithium fluoride and lithium iodide is lithium iodide only. Okay. So therefore here may simply remind covalent character increases with increasing anionic size for a given cation. Here remind that. Okay. So cation is similar but anions only change. And next, Covalent character indirectly related with cationic size. Covalent character indirectly related with cationic size. Now see that in first group of cations, from lithium ion to cesium ion, ionic size increases. Okay. On increasing cationic size, covalent character decreases. Okay. So therefore, for given anion, means in these two compounds, anion is common, fluorine is common. Okay. So just compare cations only. For small size of ions, only covalent character is more. For small size of ions only covalent character is more. So therefore, in lithium fluoride and potassium fluoride, lithium fluoride is more covalent than potassium fluoride. Okay. And next, third point, that is of covalent character directly related with charge. Charge means either cationic charge or anionic charge, what it is. Okay. So now in these two examples, chloride ion is common. Okay. So just we have to take off cations, sodium ion and zinc ion. So sodium has +1 charge, but zinc has +2 charge now. Okay. On increasing charge, either on cation or anion, covalent character increases. Therefore, in sodium chloride and zinc chloride is more covalent than sodium chloride. Okay. And next point, pseudo-octet configuration of cations of compounds are always covalent. Okay. Pseudo-octet configuration of cations of compounds are always covalent. So example, in sodium chloride and zinc chloride, already I said that pseudo-octet configuration. Zinc ion has pseudo-octet configuration. So therefore it is more covalent than sodium chloride. So these four factors are called Fagen's rules. So with these rules only we will say which compound is more ionic and which compound is more covalent. Okay. So in these factors just I explained about covalent character. If we know about covalent character clearly, then easily we find out ionic character. Okay. So covalent character directly related to anionic size, indirectly related to cationic size, directly related to charge, and pseudo-octet configuration of cations of compounds are always covalent in nature. Okay. So these are about Fagen's rules. Okay. So this much enough.